will be a little bit more clear in the next couple of minutes or in the next hour. Just up front, we are in a virtual environment, so that's why I think we are safe in terms of distance to each other. But you see, I still have this kind of mask with me. Here in my facility, I don't need it because we stay in distance and keep our safety requirements. This is, of course, the most important issue, being on site in these crazy circumstances. But that's why you might wonder, but it's okay from this standpoint. So, what we are doing here, I'm really excited to show you. This is our digital AM factory. You see a big hall, big space with lots of hardware and equipment. Me and my colleague, we will show you much more in detail in the next couple of minutes. But first of all, I would like to give you a brief introduction in what's planned here. You might wonder, or will wonder yourself, why it looks like a little bit messy, not very shiny like a showroom, because this is not a showroom. This is our production facility where we want to test our equipment, but not only testing, this is not only development, but this is production. We verify our simulations, and actually, I tell you up front, we are producing also our own parts here. That means EOS, as you know, EOS is not providing any parts to sell parts outside of our company, no, but about 5 to 10% of the parts of our machine, of our 3D printers, we produce on our own. And we are very happy to do this here in this facility, here in metal and over there in polymers, just to also own our own data and to be sure what we are doing. That means to learn, to improve our processes, our machines, and all the periphery also. So maybe just for the beginning, a very quick old school ramp up. Hope you can see it. Sorry for being old school or very with paperwork in a digital facility, but I think this will give you a very, very brief introduction in our doing here. So, in our facilities, we are working on an end-to-end solution for additive manufacturing. That means everyone is speaking about distributed manufacturing, distributed production, digital twins, and all these kinds of fancy new things going around. Many people are talking about this, many people are planning something. We are doing this. And not only since today, no, since a longer time, so this is already running. And the plan behind this, to have an end-to-end solution, that means coming from a virtual product, that means from CAD data, from the opportunity you want to produce with AM, then bringing this from this digital twin of a product over a digital twin of a production, a virtual production. Here we work very close together with partners that really know about these things, especially with Siemens for these kind of big enterprise solutions on Siemens NX, Siemens Technomatics, and all these kind of mighty and powerful software solutions. But also with very, very fancy new technology solutions like from Octon, for example, to provide this virtual reality and virtual production, this digital twin actually, but then coming from virtual environment, bringing these into real production. And this is what you will see here, over there, in this hall. Testing it, but not only testing it, verifying it. This is the idea in behind. And now I want to add a little bit more complexity. It's not only about a digital twin and then just producing it. No. Distributed production, distributed manufacture was exactly the topic what we highlighted on Formnext. And here we demonstrate it, we verify it. That means adding to our heart, to our machines from EOS, adding periphery, adding automation solutions. That means another pieces of hardware that bring complexity into our products, and then adding digital pieces on it, software solutions, like I mentioned Siemens NX, like Octon, like other bricks and pieces from software, and bringing this into an end-to-end solution. This is a very, very important part within distributed production. And here, with this closed loop, we verify it, and then we can transfer and scale it to all different sites, locations, partners, companies, and so on. Maybe not to bore you, but to show you a little bit more content, what actually now we are doing here with our team. That means starting from the design phase and qualification afterwards. You picked up the right opportunity for AM, you redesigned it, you brought it into our environment on our machines, qualification, IQ, OQ, PQ, and all this crazy stuff to be sure what you are producing, but then bringing it into our reality, into our production site. That means we together, we can make this kind of production simulations, like my colleagues Naishal and Carsten have shown you on Formnext. We can plan together the facility with different software solutions, like Technomatics, like other software solutions. And here, now we are here in this kind of verification process. We bring the digital content back to reality and verify it. And then once again, we bring this information that we measure here in our equipment back to the digital reality, to our digital twin, have a closed loop, and get better and better in the findings and informations that we get out of our production here. And in the end, sure, we can scale it and do whatever we need to do with the kind of hardware and software solutions that we developed here. So I think this is enough theory for today. Now we start our practice. What are we doing here? So, as I mentioned, this is our digital AM factory. But we are doing this not only out of fun, because it's a nice hall, obviously, and a nice environment to play around, sure. As an engineer, we are of course happy to do so. But of course, we have got also kind of products that we produce on our own for our machines. Some of you guys might use our most famous machine, our M290. So this is the grid nozzle bringing safety gas into our building chamber. In most cases, it's argon. It's a very, very complex part. You can't see through because it's a very, very specific geometry that for casting it's really not easy or even impossible to produce. So of course we print it on our own. And this one is also a kind of safety gas nozzle for M4 systems that you will see in a second over there. And these parts, these are some of the parts that we produce here for us, but these parts we want to highlight you how we bring them here through our production, and actually what are the work streams in behind. And we're not only doing this because to, I don't know, save money, save time, save complexity, is also a good point for our controlling guys. They love it. But we want to get data. This is actually what we are doing here in our digital department. One of our colleagues, he's responsible for our, we call it data lake, and he's kind of swimming in data, you know? That means he's collecting from every station, everything is under control. Everywhere you see kind of cables running out of our hardware equipment, where we collect data and then obviously analyze it, improve it, and bring it back into our production. So, I think you heard enough from me, and let's go inside and have a look what we are actually doing here. So join me. So I'm not alone. As I introduced myself, I'm Marius, but I brought also my colleagues here with me, both Dominics. And as I mentioned before, we have here also our safety restrictions, so you might wonder why we are not kind of very tight together as team colleagues, but you will understand these kind of restrictions, so that's why we will jump around a little bit. But first of all, I would like to introduce my colleagues and myself maybe once again. So as I mentioned in the beginning, I'm Marius, responsible for our digital AM solutions and within EOS, and you will see them in a minute. So I won't talk for more and will give over to my colleagues.
Hi everybody, my name is Dominic. I'm the technical project manager of all these modules here. And in this position I'm responsible for the whole development, the testing, and every technical aspect of our modules here at the test facility.
Okay, my name is also Dominic, so it's very easy to differentiate. I'm the small Dominic, he's the tall Dominic. So I'm a product line manager for the M400 and also the periphery. That means all you can see here. I have a mechanical engineering background, and yeah, now I'm responsible for the product line. And now we would like to present you our babies, I would say.
So when we are taking a look at the process chain of our equipments here, everything starts at the setup station. This is the module where the building platform, as my colleague here is holding very good, is set up and loaded into our exchangeable frame. The exchangeable frame then is the carrier object that is transported from every station to each module. And from this position we can have a transport with our IGC, the inert gas container. This can be done with the so-called AGVs, automated guided vehicles, automatically. I hope you saw it last year at the Formnext. And of course also a manual solution is available where you transport the whole IGC with a lifting trolley. So after the exchangeable frame is set up with an empty building platform, and IGC is transported to our process station where the building process starts. It is loaded in these docking stations that are positioned in front of every module. And Dominic will show you now how is it handled with the lifting trolley.
I promised my colleague that also manager can do this.
We will see if it works.
So yeah, in general you are you just move lifting trolley.
Of course we prepared it a little bit to make it a little bit easier for him.
Also for the manager. So you see here, this helps to coordinate, so it's also good for manual handling. Of course the HEV does a better job than I. Okay, and then it's in the position and the operator just has to press one button. He will be the operator.
So now the IGC is docked automatically to our process station. The connection is initiated between the docking station and the IGC. This is the situation where also process data are exchanged. For example, atmosphere and pressure in the IGC. And when this process is finished, we could initiate the exchange of the frame into our module. So we can go here. And then the transport starts. This one now will take some minutes, but after that, the exchangeable frame is stocked in our machine, where the whole innertization and process atmosphere are established to start the building job.
Dominic, while you are doing this and showing us, maybe you tell us a little bit more about the safety atmosphere, safety gas. So how is the planning behind? And what is exactly this kind of stations where you fill in your gas and everything? Maybe you just describe it also in this way.
Yeah, sure. One of the main features of this inert gas container, of course, is that it is gas tight, and it enables the control and the monitoring of a defined process atmosphere. So you can set up the oxygen value of the atmosphere where you want to store your powder and your parts. And after this inertization, you are sure that during the whole transport of the exchangeable frame, that it also contains loose powder after the building job, you always have a defined process atmosphere. And so you accomplish highest quality standards, for example, in the aerospace industry.
And also, of course, there are some sensors inside, so we do a track and trace. So it's not that we just trust there is a atmosphere, we really can measure it and track and trace it. Okay, so now the exchangeable frame is into the machine, in the printer, and now the process would start.
And guys, now it will be done automatically. Not only the muscles from Dominic will be trained, now it's fully automatically inside. And yeah, process would start then immediately.
And one of the biggest advantages, of course, is that the process atmosphere or in the process station can be maintained during this exchange. So you do not have to wait to start the next job until it's completely inertized, and this is one of the biggest advantages of this system.
Okay, and I think, as you know, the process itself will take some time, some hours, days, depends. So let's move on to the next station.
But this is now exactly an interesting point that you mentioned with the duration. So you see here a perfect configuration that the guys will explain you more and more in the next couple of minutes. But just to tell you up front, for each application or for each process, for each material, there might be a complete different setup. So this is perfectly defined for the kind of products that I've shown you in the beginning. These nozzles that might be this duration and this height, or the smaller nozzle. So for this is the perfect configuration, the perfect setup. But depending to the duration that you have mentioned, some build jobs for crazy space guys, for example, that printing these tall parts with even up to 100 kilograms, this might take not only hours but weeks. So for these long durations, there might be a complete different setup. This one is prepared for specifics that the guys will show you more and more.
Okay, so let's move on. So what you can see here, what is our unpacking station, also again with an inert gas container and a docking station in front of it. So in our unpacking station, that's the next step after printing the job. There we remove the powder from the build parts, so the powder can be used again afterwards. Also here in our unpacking station, everything will be done completely automated. So the principle is that the exchange frame is rotating, the powder is falling down, and we also help the powder to fall down via vibrating and shaking everything. So with this principle we get a really good cleaning result, and also there we have inert gas atmosphere, so also there the powder is completely inert, and from there we can bring it back into our powder circle closed loop, and the powder can be reused again. So at the moment you can see here we are still doing some long-term tests, so do not wonder why it's always moving around. We are in the last steps before our release, and now we are testing the 10-year, 15-year periods with the wear part and spare parts, and that's why we are doing these tests now.
Dominic, this would be great to do it on your own. If you pull it out and pull it in once again, it would bring you a lot of
course,
energy, I guess.
Because we are talking about 35 to 40,000 cycles that you have to do to simulate it. So it would be a good training. Okay.
Yes, the loose powder is collected here at our unpacking station. Of course, also this is done under inert gas atmosphere, and this powder then is transported via a vacuum system to our IPM and powder station L. This is our system where the powder is beneficiated, so it is sieved again, and from there it is transported to our process machine again to ensure that there's always enough powder for our building job. Also, this powder loop is completely closed, and it's always under a defined process atmosphere.
Yeah, so we have on one side the powder from the unpacking station goes back into the powder circle and goes back to the machine, but of course also there you can see a glove box. So if you want to bring in new powder into the powder circle, that's the point where you bring in the new powder. Okay, so now we depowdered our building job. Everything is more or less clean, so nearly completely cleaned. And from there now the exchange frame goes back on his journey to our setup station where we started. So that means the exchange frame in the inert gas container will be moved to the setup station again. Heavy vehicles, they need time. Okay, so we are back at the beginning. Here now the building platform with the printed jobs are taken out. Could be done manually, could be done with a lifting trolley, or could be done with a crane. So there we have different possibilities. And we bring then these printed parts into our post-processing process. So before we go there, of course, now the exchange frame is empty. That means we bring now a new build platform into the exchangeable frame, and the process starts again. Okay, and we go the way of the post-processing now.
Maybe one interesting question that came up. This is of course a big equipment. So for how many machines can you actually use this? Speaking about an AM cell and a perfect setup when you want to scale your production. So obviously this is not invented for an M100 machine, for a small one to produce dental tools or restoration or stuff. So for how many machines can you use it, or what would be ideally a setup that you would like to explore these machines?
Yeah, so of course, as always, it depends on the job, on the building job. But of course, now we have here a very small setup, but that's also because we don't have so many parts that we have to produce. Of course, if there is a customer in serial production, it's a different story. And that means one setup station or one unpacking station you can use for several M404s. So I would say it starts with 3 up to, I would say, 5, 6, 7 M400s. It's absolutely no problem. There we are more talking about redundance, that, for example, if one setup station wouldn't be enough to have this redundance, you would place another one beside, but it's just because of redundance reasons.
Because this is, I guess, a very important issue and topic regards OEE. That means when you are speaking about costs in the end, productivity, you want to exploit these systems in the best way. And as you heard my colleague, you can put many of these, and he did not, I have to challenge him, because he did not put any upper level, so he did not put any numbers there. But I guess 5 to 7 or even more machines are not a problem to plug into these systems and close them. So we have one question got right now live on this session. How long does it take to unpack? So I think I have my best colleagues here to answer the question, so I just...
So I know, but maybe Dominic, you want to tell?
Yeah, sure. As my colleagues often like to say, it's also on this question you have to say it depends on the application, of course. So typical times for unpacking are something between 30 minutes or 40 minutes. And the idea is that the atmosphere, the energization is done in parallel through two other processes, and the real unpacking duration is approximately 30 minutes.
And to add, so it's completely depending on the job, and therefore the customer or the operator can create his own unpacking receipt. That means you are completely free how long it takes. So as this unpacking process is in parallel, you also could create an unpacking receipt that takes, for example, 2 hours. Because in general, it doesn't matter, it does not influence the OEE because it's in parallel to the printing job. So if you have a job that is not that easy to clean, you can take more time. If it's a really easy job, with a half an hour, it's done. So I think I hope we answered the question in the best way.
But maybe this is also a good topic regards how many of these systems you need in the end. Because just imagine you would have, for example, a very short duration of a build job, taking into consideration our nozzles. It takes few hours to print them. And for example, when you need a huge quantity, then maybe one of these systems will be then completely booked out for service, let's say. And this is something we can do in our simulations. Now back again in our digital twin, where we directly simulate if there's a kind of bottleneck in doing any kind of operations or post-processing. So maybe we just go then furthermore in direction of our post-processing and then have a look what we do there.
Yep. To you.
Yes, as Dominic already told, the empty building platform with the job is extracted out of our setup station. This can be automatically, example, with a robot, as you can see here in the background. It's not fully running, but this will only take some weeks. And this robot is putting the empty building platform in a separation step. Here is it's a saw, and from there it is transported to our post-processing step machining, like you can see here in the background.
So maybe let's get there.
Yes, I think Marius, you probably can explain it a little bit better what the idea is from extracting it out of the saw from the building platform separation step to our machining step.
So in general, when we are speaking about our solution for a digital factory, we want really to have a solution. That means it does not end with the kind of powder handling and our service that we do at EOS. That means with everything regards material process and machine for additive, but also machining the parts and have really a solution like you see it now in your hands. That means this is really a state-of-the-art setup using automatization like this KUKA robot in behind and this Casto saw in order to bring on the AGVs that you saw in the beginning automatically into this after unpacking. You bring it out to the robot, it picks it up, the whole build plate, after it was depowdered, and then it loads the platform with the parts into our Casto saw, and automatically it gets the process is done. But in addition to this, what we are testing here, and these guys might punish me when I tell you, but I just do it, we make really state-of-the-art post-processing here that we do not need any kind of a grinding process for finishing the build platform to reuse it. So this is really something unique in the market now, that we drive here processes where the cutting process is so dense to the platform and so precise with a saw. I am not speaking about EDM wire cutting or stuff like this, but with a typical saw from Casto, where we can really develop it for immediate reusage and have our powder plate recycling system automatically in this setup. This saves you money. This is what we are working for here, to improve productivity and decrease costs, of course. So the perfect OEE for your factory setup. And as I have shown you, in the beginning, this is highly scalable. So for sure, for one machine, this saw is just waiting on work, on build jobs, for sure. But when you have a highly production running, then this is extremely productive.
And maybe just to add, so of course we don't want to be in the saw business in the future, but why are we doing this? It's exactly what you said, Marius. We want to show that the whole process, not only just the printing, we want to show the whole process and to see that there you can get a really good OEE and that you can really produce the part cost efficient with the whole process chain.
Exactly, and as you see here, guys, this might be even an open invitation to you. This is a big hall, and behind the curtains, the hall is even bigger. But this is something I think I would get punches if I would bring you there from these both gentlemen, and yes. I'm alone. So
Yes.
I think I do not want to dare it to get these punches today, maybe someday afterwards. But what I want to say, it's an open invitation for you guys. If you have some, let's say, exciting technologies that you might add to this process steps, hey, feel free to contact us and bring your ideas inside of these walls here. So this was one step. Now you have the parts in your hand. They are kind of removed from the building platform. They are loaded on a transport vehicle again, and then we move on to our final process step within for these parts with our CNC machine. Come on. So what we see here, this is not the fanciest one. It's a good working CNC machine, so there are many of these that work really well. But here we have chosen this one, a more or less simple model, in order to fulfill the operations that we need for our parts running here. And with this cobot, fully automatically, parts are getting picked up from the transport vehicle, being placed here in this table. We will show it to you maybe in a few seconds, but they will be placed here. Then the cobot takes them automatically into our CNC machine, and all the machining operations are getting done. So here you see some of these frames that we need then also then to pick them and so on. And yeah, after machining, you have then your final parts, your final components that we can then check also in terms of quality control and so on. We do not highlight topics about quality assurance and quality control right now, because this is maybe something, I would say, a little bit proprietary, that if you're interested in, you can just text us. But we've got plenty possibilities to check quality during build job, during the job is running, but also we have some measurement possibilities after cutting off the build plate and also after CNC machining. But I think this is topics about hours, speaking about qualification and so on. And this might be, I guess, another session where we invite you then to speak with my colleagues then, for example, from Additive Minds and also from development departments to speak about this qualification topics.
And maybe I can jump in because I really like this. So this is a good example for some smart developing solutions. So because it's a completely automated process, but it's not because we connected it to another system. It's just the robot brings the parts in, and to start the job or the milling automatically, the robot presses manually the button. So it's pretty simple, but it's an automated solution, and I really like this. And so in this case, we don't have to connect this milling system to a control center, but that's also a good link to this control center, because we have, of course, all the other machines connected together. That means we have a control center developed by our software departments that it's completely shaped to a AM process and to the AM machines. So what Marius told you, that there of course are a lot of possibilities to talk about quality and so on. Of course, the data gathering, everything can be done with this control center. So everything is gathered together. You can analyze the data. You can also do this automation of the completely circle. So what you saw, that we press the button to start. Of course, this has to be necessary. If you have the control center, then the control center takes over this job. So yeah, is there anything more to add to our control center?
I think it was exactly the perfect next step to bring hardware together with software. So now it was very much hardware related what you saw here, but especially what I mentioned some minutes ago regards quality. Of course, also software and data can make some bugs and stuff like this. I think all of you know this using Windows and stuff, but especially speaking about software solutions, having another quality level. That means you collect data, you have algorithms to check all your data and to check if the process is in the right direction, and then also to improve it. That means you get a higher quality level and also documentation. This is last but not least, of course, one of the most important issues for quality-related industries like medical industry, like aerospace industry, space industry, and other quality-related sectors for sure. So maybe to give you then the last overview of our facility here. So as we mentioned before, this is kind of really a flexible setup. That means nothing is now here made out of stone. It's made out of aluminum or Inconels, as you know, or PAL12s over the wall. No, but it can be changed. It can be removed. It can be rearranged to the specific needs that we have to produce parts for ourselves or for the verification process that we run together with our partners and the companies that are interested in this. And only to give you an outlook and of course to speak about next invitations.
You are allowed to say this.
Yeah, okay.
So we cannot see behind the curtain, but we can have a look for the empty space.
Yeah, then Dominic,
No,
maybe
no,
you.
no.
Oh, it's a great honor for me, you know, when he allows it. So here you see already kind of first indications are there. So here we will have the setup of our latest machine technology, the M3, the M304 with 4 lasers operating. Here we plan to have an additional material tested here in our facilities together with the M4 system. That means on the M4 we have aluminium, but on this specific M3 that will be installed, I tell you, he's looking in another direction, in exactly 2 months from now. I'm really happy and excited to get these machines right in this hall. So I'm really, this is Christmas for me. So this machine will run on a kind of Inconel or a kind of cobalt chrome material. Maybe if you have some specific wishes, please let us know. We are still not prioritized which material it will be, but it will be kind of an high strengthen alloy for high temperature usage in gas turbines or in aerospace or space applications. And here, the interesting part will be, we will have a quite similar setup of an AM cell like both Dominics described you here with the M4 setup. But in addition to this, we want to use post-processing and these kind of AGVs and other components and hardware for this line, also for this line, to join the equipment and also once again here to get a higher level of productivity, better usage of your hardware, of your investment, and get a better OEE in the end. Lower your costs. So this is exactly what we only not want to show here, but really to verify and prove. And as you see, there's still place to bring also you into this shop floor.
Yeah, and maybe just to add, very good explanation. Just to add, so what we seen over there, the shared modules solution for the M400 will be released now very soon. And the same solution also works for the M300. Of course, you don't want to hear it, but we have to test it before we release it, so it takes a little more months till the release, but it will be the same system. It's just to be tested with the machines. But yeah, so we are ready.
Oh, I see. We have another question. Maybe you just stream it to us. Hope you can answer it. So let's see.
Our colleagues are a little bit shy. They don't want to ask it loud.
But very soon, especially when all these kind of travel restrictions are over, then you for sure can also visit us here in person and see how things are moving on. Okay, so the question is, what impact has automatization on cost per part? Do you want to add on this, or we make it just jointly maybe?
Jointly, yes.
So, as both gentlemen described in the beginning, each setup is highly dependent on the specific part, material, process, and in the end the duration of the build job. So that means I can just say maybe in general, so when you have a very short duration of a build job, then for sure automatization might be very, very interesting. When you have got the very, very long durations, especially for crazy space applications, that takes hundreds of building hours, and you don't own 100 M404 machines, then automatizations might be not so successful. But just showing it for you, for the parts that I've brought up for our own systems before. We simulated everything. And we directly have shown, not only by simulation, but also verified here in this setup, that we could save costs only using automatization about 40%, 40. This was crazy. So comparing apples with apples, when you assume here at EOS we work in a one-shift model, that means 40 hours per week from Monday to Friday, and taking this into consideration, it saved about 40%.
Okay, and maybe just to add, because to make it a little bit more specific, so I think it's easy to imagine that if you have a build job, if you have a one-shift model, if you have a build job that stops during night, for example 10 o'clock, then you have to wait from 10 o'clock till the next shift starts. It's about 8 hours, or yeah, depends. And during this time, the printer stops. So there is no no usage of the printer. If you have an automatization, then after stopping the first job, the next job starts automatically, and it's even more effective during weekends, as you can imagine. So if Friday night some job will stop, you have to wait until Monday till your operator comes back to the company and starts the next job. With an automatization, you start directly and you have a lot higher usage of the machine. So maybe this makes it a little bit more specific.
Okay, so I think there are two main aspects that cannot be forgotten, and that is, one is the health and safety issue. This is probably addressed with the automation very well. And the second thing is quality assurance. Of course, you can be sure and to ensure the quality with our automated system, and these are indirect costs that directly lowers your cost per part in the end. So beside of course, the time effects that my colleagues described, these two aspects should be considered.
So I just get from my colleagues here another question. It was asked about third-party equipment. If we are willing to bring more third-party equipment into our digital AM factory. I can just say yes, 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 for sure. As you see here, we are focused on our heart, on our AM machine, on our AM printer, like the M4 or the M3 that we install in 2 months here. But for sure, especially in terms of automatization, in terms of post-processing, all the steps that are necessary to have and to fulfill in order to have a final part and have a solution in the end. Not only a lot of powder and a base plate not machined, for sure not. We are very, very happy if we get this input and the kind of partnership with you guys, if you're interested with us to collaborate. So as you know, us, EOS, we really try our best to be open, our machine, our software, that you can plug it into your software environment. This is not a kind of a crazy spaceship landing in production. No, we want to be open with our interfaces in the machine that you can plug it into, let's say, third-party equipment, not from EOS. We won't be able to focus on all different kinds of post-processing steps afterwards. Therefore, we need partners. So if you're interested, just reach out to us, to me, to my colleagues, or just on eos.info. And for sure, we are very, very happy to see if there are possibilities to do this together. So I think I get the signs from my colleagues here that we run out of time. So I think we were very, very happy that you joined us here live in our AM production facilities here in Maisach. So I hope we could answer at least some of your questions and give you a little bit info in what we are allowed to. I see if I get any punches, but I'm good for today at least. So if you have any more questions, or as the last question, if you're willing to collaborate with us in terms of having a solution, and we're speaking about an end-to-end solution, then just reach out to us. So maybe you want to add something, Dominic?
No, I'm fine.
I hope you enjoyed the trip, and we hope that there are some questions left. And of course, you can address them. Just leave a message or contact us.
Now, last words to you.
I'm fine. I think you already said everything. So I was really happy to present our babies, as I said at the beginning, and hopefully we see us soon.
Okay, guys. So thanks for joining us. Have a good one, and hopefully see you soon.
Bye. Take care.
Bye.
Bye. Hey.